Okay, so chapter 7, section 2. Oops. All right, the forming of ionic bonds and the characteristics of ionic bonds. And I'm not sure that we'll get through all the characteristics today because our first focus is going to be on how ionic bonds form. And in order to know how they form, you have to understand valence electrons and those electron dot structures that we did in section 1. So that's why we practiced that skill before we moved on to this. All right. So our objectives, first thing that we need to be able to do is I want you to use electron dot notations to demonstrate how the electrons transfer to form an ionic bond. So that's our first focus. Our next focus will then be explaining the observed characteristics of ionic compounds with reference to how their structure is put together. So first up, ionic bonds. The ionic bonds form when electrons are gained and lost. Okay. And when they gain and they lose, they form cations and anions, which are positives and negatives, which are attracted to each other. So in an ionic bond, we are going to lose and gain electrons. It is going to create a mutual partnership between the elements involved. Cations need to give away an electron, and anions need to gain one. So it's a great relationship. They help each other out. It's a mutual partnership. We can demonstrate this using electron dot notation. And that's what I'm going to switch to my camera and we're going to do some electron dot notations. All right. So an ionic bond is formed when electrons are transferred between. One of them is gaining, one of them is losing. And because of that, they are in, like it's a great relationship between the two. Let me switch to my camera so I can show you what that looks like because this is going to be part of your job. Come on. All right. So if I wanted to show the bond forming between, let's do this one as our first example, sodium and chlorine. The first thing that you would want to do is you would want to write the electron dot notation for each of the elements involved. So I locate sodium on my periodic table. It's Na. It's in group 1, so it has 1 valence electron. Then I'm going to put myself a plus sign because that's what I'm doing is I'm showing how these are going to bond together. And I locate chlorine. Chlorine is in group 17, so it has 7 valence electrons. All right, can you see how this is going to work? Really well. Sodium has 1, and what does it need to do with it? Get rid of it. Chlorine has 7, and it really needs 1. So we're going to use an arrow to demonstrate that sodium is transferring this electron from sodium to chlorine. When that happens, we have created a compound, and I have one sodium and I have one chlorine. That's it. So I'm going to use arrows to show how the electrons move. And then I'm going to write the formula of the compound that would be formed based on what I see. A lot of if you have a group 1 and a group 17 element, it's always going to be 1-to-1. If you had a group 2 and a group 16 element, that's going to be a 1-to-1 ratio. They're going to work out pretty quickly and easily. But it doesn't always have to be that way. Any metal can bond with any non-metal. For example, let's say we have lithium. Lithium is a group 1 element, so it has 1 valence electron. And let's bond it with sodium. Sodium is in group 16, so it has 6 valence electrons. Now, lithium is still needing to get rid of an electron, and sulfur is still needing to gain electrons. So lithium is going to go ahead and say, hey, works for me. You can have mine. And it goes right here. Now, this lithium is happy. It's good. But does sulfur have enough electrons to be stable? No. How many electrons do we need to be stable? 8. And right now, sulfur only has 7. Remember, that doesn't rhyme with great. So it's going to take more than 1 lithium to make sulfur stable. So I'm going to have 2 lithiums. And then this lithium also gives away its electron. Now I have 2 lithiums that are stable. They gave away the electrons they needed to. And I have 1 sulfur that is stable because it got the electrons that it needed. So when I draw this one out, I have to indicate that there's not 1, but 2 lithiums. So I put Li2 and then S. Questions? Maybe? What do you mean? Electrons? There's 8. Because there's a 1 is understood, and there's 2 lithiums, and there's only 1 sulfur. And we don't have to write ones down. We just understand that they're there. That's a good question, though, and it's something that I see happen a lot. We just understand that 1 is present. We don't have to write those down. Just like up here at the top, I didn't write Na1 and Cl1. We just know that there's 1 and 1. All right, let's give you one to try then. You try this one at your desk and just see if you can write the correct formula. Let's do barium and fluorine. I'm gonna give you a minute there to work on those and see if you can write the correct transfer and formula for barium and fluorine. Yes. It's number 56. All right, you can check your work against mine. See if you got it right. If you got it right, yay. If you didn't, let's ask questions so we can get where we need to be. Anybody have questions? Yes. Because if I look here, there's only one spot for barium to give away one electron. Okay. So that would leave barium with one of its electrons, and it doesn't want those. It wants to get rid of both of them. And the only way to get rid of both of them would be to have two fluorines. Yes. What do you mean? Like barium plus fluorine? Yes. You have to write the middle first and the non-middle second. And I always write them out where the middle's first. I mean, so it should flow pretty easily. I don't make it tricky. I wouldn't have the fluorine plus barium and then expect you to write barium fluoride. Other questions, because those are great. All right. Well, then we have that. We'll come back and do characteristics on Wednesday. Tomorrow's ACT day. So Wednesday we'll pick up with the rest